Hello learner, welcome to Manifested e-learning platform. My name is F.A. Ngwiri and I practice within the financial services industry in Kenya. Today, ladies and gentlemen, we are discussing about portfolio management and focusing on active portfolio management. We will dive a mile deep to discuss about concept of value added there. And we need to bring forth the following point, guys, the following point. That for an active manager, the information ratio, which we had highlighted in our previous lesson, information ratio can be viewed as a budget constraint, can be viewed as a budget constraint as follows. An increase in the active return, active return, this should be small, pardon me, active return will require an increase in risk. So increase active return will require an increase in the active risk, should be active risk. And so we are saying that this concept that was presented to you in our previous lesson, where we have alpha is equals to the information ratio times the active risk. This is the active return, this is the active risk, and this is the information ratio. So we can rearrange this and say that the information ratio is given as the active return, which is the alpha over the active risk over there. Because we had mentioned this concept in our previous lesson, I'd really urge you to look at previous lesson, and we can draw this relationship right down over here, guys. And we say that, of course, this is going to be active return over here. So active return, this is active risk there. And we draw just a line, just like so. And that line would mean that for investors who want increased returns, they must be willing to take up increased risk there. And that is a portfolio concept that has been actually been measured and actually been researched on extensively. Now, we discuss then, therefore, on this other side, guys, about value added. So we say that value added results, value added, and we just underline that there, and we say the objective of active management, is to maximize value added, value added, which you're saying is VA, like that. But what is VA, ladies and gentlemen? VA, or value added, is a metric that attempts to capture the trade-off between, put a hyphen there, guys, between active return, and active risk. Active return and active risk. We stop there for a moment, guys. Let's just discuss slowly what we've actually just written. Value added. The objective of active management is very key, is to maximize value added there. But what is VA? VA is a metric that attempts to capture the trade-off between active return and active risk. Active return and active risk is very important. So we proceed on and say that the value added, VA, is given as the following relationship: active return less lambda times active risk squared. That. So we are saying that alpha represents active return, this sign over here, it looks like a W, represents active risk. But what is lambda? Lambda there, guys, we're saying is the residual risk aversion component. Residual risk aversion parameter or component. So what is the implication of that, guys? We just need to note that the higher lambda, the greater the risk aversion. Higher lambda means the greater the risk aversion. The greater the risk aversion. Close the bracket there. The higher this component, the higher the ability of investors to avoid taking up increased risk. Very important concept over here, and it is even applied in practice or in the financial services industry extensively. So we move over on this other side so that we can build on that knowledge, guys. And we say that VA, value added, is higher for a manager with higher alpha, lower risk aversion, and lower residual risk, risk. VA, value added, can be thought of as a risk-adjusted excess return. Can be thought of as risk-adjusted excess return. What does that mean? We explain that, guys. Alpha is discounted for higher residual risk, higher residual risk, or higher risk aversion, or higher risk aversion. Let's stop there for a bit. we're saying that value added, of course, we explain what value added is. We said value added is given as the alpha minus, you're saying over there, the lambda times that component squared, like that. So we're saying that value added is higher for a manager with higher alpha, lower risk aversion, this is the risk aversion component, and lower residual risk. This component should also be lower, and this should be higher, like that. Value added can be thought of as risk-adjusted excess return. That is, alpha is discounted for higher residual risk or higher risk aversion. So having said that, I can be able to just demonstrate what we've just discussed here in form of a graph, a small graph right here. So the graph is like so. And we're saying that this component is residual return. That arrow is important because it shows that it is increasing like that. And this arrow as well is also important because it shows that it is increasing as it moves towards the right. And this is residual risk. And we have what we call parabolas, which are graphs that tend to ebb as they move towards the top, like so. So we have this kind of parabola, like that. Then this one also ebbing like that. And then this one can be a continuous line that can be parallel towards those other two there. So this is when value added is equals to 1%. Value added is 1%. This other one here is when value added is equals to 2%. And this final one over here in form of arrows like that is when value added is equals to 3%. So in short, we are saying that as we reduce our residual risk like that, then we tend to get higher value added components. Higher value added components is very important over there. And the best way to just try and describe this concept over here is by looking at an example. Jackie is a value manager with First Partners LLP. Jackie estimates that she can generate residual return of 3% annually. Jackie's residual risk is 6.5%. Compute the value added for part A, an aggressive investor, that is the lambda is 0.05. B, a moderately risk-averse investor, that is lambda is 0.1. And a conservative investor, that is lambda is 0.15. So we know the formula to apply, guys. The formula to apply is this one for value added over here. And you can see very clearly over here. Just highlight it for you in form of a bracket over here in style, guys, because we are all FAs, financial analysts. So we're saying value added is alpha minus lambda times this component of residual risk squared there. So what we can do, come over on this other side here. So solution there. And we have been informed that the aggressive investor has. So first of all, we write the formula, value added, we rewrite it, we know what it is over here, alpha minus, and we have the lambda times that squared, residual risk squared. So for A, aggressive investor, there. So the workings now should be in black. And we just say, because we have already been given this component, this risk as 3. So VA is equals to 3 minus. What is our lambda? We're saying our lambda is 0.05. over here I should have put 0.05, lambda 0.05. Should have put it like that so that we can see our lambda there. So we're saying is 0.05 multiplied by what is our residual risk? Our residual risk has been given to us there 6.5%. So 6.5 squared like that. So how much do we get as our value added there? So we work it out. So it's going to be 0.05 multiplied by 6.5 squared equals, and then we get 3 minus that answer. So 3 minus the 0.8875. So we have 0.8875. And what does that mean, guys? That means it is 0.89%. 0.89% or 0.89%. That's the value added for the first case. B, we have a moderately risk-averse investor. So risk-averse investor. Once we're talking about risk-averse investor, what is the percentage? So lambda is how much? 0.1 by there. And what is the working? Remember our VA, the formula is there, so our VA is given as the 3 remains, but what changes is the lambda there, minus 0.1 times what is 6.5 squared, 6.5 squared like that. So how much do we get as our VA? Is equals to how much? So we just get 0.1 multiplied by 6.5 squared like that, and then we get 3 minus answer, we get negative 1.225 or negative 1.23, you can see that. Negative 1.225 or negative 1.23% like that. C, finally, guys, we are saying that conservative investor. So this is risk averse. So this is conservative investor. That is, lambda is how much? From the question is 0.15. That. So once we have that, we just put down the formula. We have VA is equals to, we have 3 minus, this is the one that's changing, this value here, the lambda, 0.15, multiplied by how much? Multiplied by 6.5 squared, like that. So how much do we get as our VA? It's equals to how much? VA, so we calculate that. So 0.15 times 6.5 squared is that. So we get 3 minus answer, you get 3, negative 3.3, negative 3.34, negative 3.34, that's it. So negative 3.34% like that. So these are the answers over here, of course. We're just rounding them off for simplicity's sake there. So we're simply saying what? We're simply saying that the value added tends to decrease. The value added tends to decrease as the investor's risk aversion tends to increase. And that is very important. So we can write that concept just over here, just to make sure that we have understood it very well. So we can say that the value added decreases as value added decreases, and that concept is actually being explained there, as the risk aversion, as the investors' risk aversion increases. That's it. Value added decreases as the investor's risk aversion increases. That. So, guys, this is the end of this lesson, concept of value added. I will leave you with an assignment that you can go and reflect on. Assignment. The assignment I have for you is November 2016. November 2016, question 2A. 2A, right there. I hope you have enjoyed today's lesson. Thank you for being with Manifested Publishers. Be blessed.